We'll now apply the YOLOv10 model to the dataset we created using Annotate Lab for ripe and unripe tomato classification. YOLOv10 is the latest version of the YOLO You Only Look Once family of object detection models, which has a reputation for fast and accurate results. We'll start by preparing our dataset for training the YOLOv10 model. Our tomato ripeness dataset contains images and corresponding annotations, which indicate whether a tomato is ripe or unripe. Before training the model, we need to split the dataset into training and validation sets. This ensures the model is evaluated properly during training. Let's define the base directory for our dataset. Since we're working in Kaggle, we'll point to the correct path for images and labels. After specifying the paths for our images and labels, we'll create the necessary directories to organize the training and testing images. Next, we'll split the dataset into training and validation sets using an 80-20 ratio. 80% of the data will be allocated for training, while the remaining 20% will be reserved for validation. Here, we use the train test split function from scikit-learn to randomly split the dataset into training and validation sets. The images and their respective labels are copied into separate folders, train and val. Now, our dataset is prepared for training. Now we need to customize the YOLOv10 configuration. We'll create a dataset YAML file that specifies the paths to our train and validation sets, as well as the number of classes. In our case, we have two classes, ripe and unripe. This configuration file is essential for YOLOv10 to know where to find the training and validation data and the number of classes. Let's now load the YOLOv10 model and train it using the custom configuration. We'll train the model for 130 epochs to ensure it learns how to classify ripe and unripe tomatoes accurately. You'll see the loss and performance metrics being updated as the model trains. After the training is complete, the best weights will be saved and ready to be used for inference. Once the training is complete, we can test the trained YOLOv10 model on images from the validation set to see how well it classifies ripe and unripe tomatoes. In this example, we load the model and test it on a sample image from the validation set. The results show the bounding boxes and the classification of tomatoes as either ripe or unripe. Now, we'll export the trained model weights for deployment. We'll use the best weights from our training session for deployment on Hugging Face. Now that your model is ready, you have two options. You can create your own Gradio app for ripe and unripe tomato detection, or simply clone our pre-built Gradio interface from Hugging Face. This gives you a quick and easy way to deploy your model. Just clone the app, update it with your best model weights, and you're all set. Feel free to experiment further. You can train the model on different datasets, adjust the model's parameters, or enhance the Gradio interface for more advanced features. Hugging Face Spaces and Gradio make it simple to build and deploy powerful AI applications. Congratulations on completing this tutorial. We've walked through the entire process of using the YOLOv10 model for ripe and unripe tomato detection. From dataset preparation, model training, to deploying the model using Gradio for image and video classification, you now have the foundation to build a complete machine learning pipeline.